Our Milky Way galaxy is a majestic swirl of stars, gas, and dust. It's a cosmic dance floor, billions of stars strong, but at its heart lies a silent, invisible giant, Sagittarius A for short. This is no ordinary resident, it's a supermassive black hole, a point in space where gravity is so intense that nothing, not even light, can escape. SGR-A* is the anchor of our galaxy, holding it together and influencing everything around it. It's a source of immense power and mystery, a cosmic enigma that continues to fascinate astronomers. Studying this behemoth offers a glimpse into the most extreme environments in the universe and helps us understand the evolution of galaxies like our own. Imagine a place where the laws of physics as we know them break down. That's the reality of a black hole. SGR-A*, though millions of times smaller than the Milky Way, commands the entire galaxy with its incredible gravitational pull. Don't let the quiet fool you. SGR-A** is a sleeping dragon. It's a monster in terms of mass and density. This black hole packs the mass of 4 million suns into a space smaller than our solar system. Imagine squeezing all those suns into a space that could fit within the orbit of Mercury. That gives you an idea of how incredibly dense SGR-A* truly is. And this incredible density gives it an almost unimaginable gravitational pull. SGR-A* isn't always quiet. It goes through periods of activity when it devours nearby gas and dust. When this happens, SGR-A* lights up, emitting bursts of radiation that astronomers can detect. These outbursts provide valuable clues about the black hole's feeding habits and its impact on the surrounding environment. The story of SGR-A's discovery begins in the 1970s, not with visible light but with radio waves. Astronomers using early radio telescopes detected a powerful, compact source of radio emissions coming from the center of the Milky Way. They couldn't see it directly, but the signal was clear. As technology advanced, so did our ability to study this mysterious object. The Very Large Array, VLA, and other powerful radio telescopes provided sharper images, confirming the existence of a supermassive object at the Milky Way's heart. But the ultimate breakthrough came in 2019 with the Event Horizon Telescope, EHT. This global network of telescopes, working in unison, achieved the seemingly impossible, capturing the first ever image of a black hole's shadow. This image of SGR-A*, released in 2022, sent shockwaves through the scientific community and beyond, providing visual confirmation of what was once only theoretical. Section 4. Stellar Ballet, unveiling the dance around the black hole. SGR-A* may be invisible, but its presence is impossible to ignore. Astronomers can track the movements of stars orbiting the galactic center. These stars aren't just drifting aimlessly, they're waltzing to the tune of SGR-A's powerful gravity. One star, in particular, has been instrumental in our understanding of SGR-A*, a star called S2. This star whips around SGR-A* at an incredible speed, completing an orbit in just 16 years. By carefully observing S2's orbit, astronomers have been able to precisely measure SGR-A's mass and confirm its compact size, providing further evidence of its black hole nature. Section 5. A cosmic conductor, the influence of Sagittarius A*. SGR. A* isn't just sitting there, it's a dynamic force at the heart of the Milky Way. Its gravity shapes the galaxy, influencing star formation and regulating the flow of gas and dust. Understanding SGR-A* is crucial to understanding how galaxies evolve over billions of years. It's a two-way street, SGR-A. The gas and dust that fall into the black hole provide it with fuel, causing it to flare up and release energy. This intricate dance between a supermassive black hole and its host galaxy is a key area of research in modern astronomy. SGR-A* is a constant reminder that the universe is a place of both incredible beauty and terrifying power.